All right, so I said in the last video that the two things we need to be able to do with inequalities is graph them, which I've already gone through and I'll go through again in this video, and also solve them. Okay, so in this video, the two I did, I just got x is less than or equal to 3, x is greater than -4, okay? When we're, say, solving an equation, that's what I want. I want x is equal to something as the final line in my answer. So when you're just asked to graph x is less than or equal to something, x is greater than something, x is greater than or equal to something grand, you can just go ahead and graph it. If you were to get something like this, 3x is less than or equal to 15, we wouldn't be interested in what 3x is less than or graphing 3x. We were always interested in just graphing x. So I would need to solve this first, okay? The rules for solving these are pretty much the same as equations, and there's one small difference which I'll cover in a separate video, but everything I'll do today will just be kind of following the treatment from equations. So 3x is less than 15, okay? If that said 3x equals 15, how would you solve it? You'd bring the 3 over and multiplied by 3 becomes divided by 3. Or else, another way to think about it, divide both sides by 3. Okay, so x is less than or equal to 15 divided by 3. So x is less than or equal to 5. And that's you done. Okay, so if 3x is less than or equal to 15, then x is less than or equal to 5. So just divided both sides by 3, just like I would for an equation. This one here, 2y minus 5 is less than 8. First thing I do, bring the minus 5 over, it becomes plus 5. So 2y is less than 8 plus 5. 8 plus 5 then is 13. Divide both sides by 2, so y is less than 13 over 2. And you can leave it like that. You can write it as 6.5, you can write it as 6.5. Same thing. Okay, so it can give you fractions just like an equation can. So y is less than 6.5. This one here then, 7b plus 3 is greater than or equal to 5 minus 3b. So letters to one side, numbers to the other. I'm going to get my letters to the left hand side here. So if I bring minus 3b over, it becomes plus 3b. So 7b plus 3b is greater than or equal to, if you bring plus 3 over, it becomes minus 3. So 5 minus 3. So 7b plus 3b is 10b. It's greater than or equal to 5 minus 3 is 2. So 10b is greater than or equal to 2. Divide both sides by 10. b is greater than or equal to 2 over 10. Simplify the fraction. So b is greater than or equal to 1 over 5. And that's you. Done. Okay, so you know, we would be able to do those anyway. If there was an equal sign there, that's stuff we've been doing for a while and we know how to do that. Just one thing to note on this one, I brought the b's over so the b's became positive. I would try to do that if I can on inequalities. If I brought the 7b over and I got minus 10b over, it's when you try to sort something like that out that these are a little bit different from equations. So if you can avoid it, I would try to make your unknown have a positive coefficient, so plus 10b here. Okay, so don't, as I say, bring the 7b over and be dealing with minus 10b. That's when you just have something else to remember. And as I said, I'll cover that in a separate video. So if you can, positive coefficient on the unknown, on the variable. Now, what I'm going to do is solve and then graph a few linear inequalities. So I'll start with these ones over here. So it's like I had on the other video, it's the same one 3 times. I'm just asked to graph it in different number sets. Okay, so natural numbers, then integers, then real numbers. All right. The way you solve it is the same for all 3. Okay, you just solve it like you would an equation. It doesn't matter what number set you will be graphing it in. That matters down here when you start actually graphing it. So you just need to solve this once. So you've got 2x plus 10 is greater than 4. So first thing I'll do is I'll bring the 10 over. So 2x is greater than 4. If you bring plus 10 over, it becomes minus 10. So 2x is greater than 4 minus 10 is minus 6. Then divide both sides by 2. So x is greater than minus 6 over 2. So x is greater than minus 3. So there's your solution. X is greater than minus 3. So that's what you're graphing for each of them. X is greater than minus 3 in natural numbers, then in integers, then in real numbers. So I don't need to solve it twice more. All right, so first one is my natural numbers. So I've drawn these out in advance, but just x is greater than minus 3. So what I would do is just go a couple down from minus 3 to minus 5, and I would make sure I get up into the positive and go a couple into the positive, so up as far as 2. Okay, so if I'm graphing x is greater than minus 3, I think down as far as minus 4 or minus 5 and up as far as 2 will give you enough room to kind of answer regardless of what number set you're doing them in. So for natural numbers, what natural numbers are greater than minus 3? Well, minus 2, minus 1 and 0 are all greater than minus 3, but they're not natural numbers, okay? So they're negative or they're 0, which are not natural numbers. So the first natural number on that, which is bigger than minus 3, is 1. And the next one then is 2. And then if I add it on the number line, 3, 4, 5, 6, all the way up to plus infinity. So I'm just going to mark in the arrow there to show that I know that would continue on. All right. Next one then is integers. So integers which are greater than minus 3. So wouldn't include minus 3. Okay, because it's greater than, it's not greater than or equal to, so just kind of pay close attention to what symbol's in the question. Minus 2 is greater than minus 3, and it is an integer, okay? It is a positive or negative whole number. So in integers here, we're bringing in these negative whole numbers. We're bringing in 0 to our solution as well. And 1 and 2, and again, it would continue up to positive infinity, so just you just make it quite clear that you're putting that arrow in, you know it's going to continue on. Last one then is I'm graphing real numbers. So real numbers greater than minus 3. Okay, so real numbers is everything, okay? It's positive, it's negative, it includes fractions and decimals this time, so it includes all the numbers in between the whole numbers, all right? So it would include everything between, say, minus 2 and minus 1. It would include everything between minus 3 and minus 2, but we're only graphing greater than minus 3, so it won't actually include minus 3, all right? So this line that we're going to draw for real numbers is going to go down as close to minus 3 as it can without ever touching minus 3. So it would include minus 2.99999, etc. So the way we show that is we put this kind of hollow circle on minus 3 to show that it goes down as close as it can to minus 3 without ever actually hitting it. And then it's greater than that, so it's everything to the right of that, and because it includes all the numbers in between the whole numbers, I'm going to go over that line. And then again, put the arrow in because it is going to continue to plus infinity. All right, so the line is showing you that it's not just hitting the whole numbers, it's including all the decimals and fractions in between them. All right, so that's the same inequality graphed into 3 number sets. So you see you get quite different answers on the number lines. Over here then, same thing, same inequality, and just ask to graph it in 3 sets. So I only need to solve it once. I'll do that here. So 4x minus 11 is less than or equal to 3. So first thing, bring the 11 over. So 4x is less than or equal to 3 plus 11. So 4x is less than or equal to 14. Divide both sides by 4. So 14 over 4. I mean, you can simplify it to 7 over 2. What I would say here is I probably would write it as a decimal because I'm not exactly sure where 14 over 4 goes on the number line, okay, in that form. All right, so I would just put 14 over 4 into my number line. It's 7 over 2, so it will be 3.5. So x is less than or equal. So I know exactly where 3.5 goes. Okay, 14 over 4, not sure. 3.5, I know where to put that on my number line. So same thing, I'm going to be graphing it for natural numbers first, then for integers, and then for real numbers. So for natural numbers, again, just when I was drawing these number lines, I know it's going to be less than 3.5. So I went a couple up, I went to 5, and I went down to -2. I went into the negative, okay? So just a couple into the negative -2 and a couple up from 3 to 5 will give me enough room to answer all of these and to show I know what each of the 3 number sets means. So natural numbers less than 3.5. You can put 3.5 on your number line if you want to. Look, we know where it is, but if it helps, if you want to put it on, you can just make it clear you're not actually marking it for the number line. I'm going to show that the same way that the points on the number line are. So what natural numbers are less than or equal to 3.5? Well, 3.5 is not a natural number because that's not a whole number. So the first whole number, which is less than 3.5, is 3. So dot on 3. 2 is included. 1 is included. 0 is not. Okay, so natural numbers, just positive whole numbers, doesn't include 0, doesn't include the negative numbers. So I'm not going to put it on -2 or -1. Integers here, so it's positive or negative whole numbers less than or equal to 3.5. So 3, 2, 1, includes 0 this time, includes -1 this time, includes -2 this time, is going to include -3, -4, -5. So this time I will put on my arrow to show I know that continues. Didn't put on the arrow here on natural numbers because it stops at 1. It doesn't include 0, doesn't include -1, doesn't include -2, isn't going to include -3, -4. So no need to put the arrow on. With this one, is going to continue on -3, -4, -5. They're all integers less than or equal to 3.5. So I put the arrow in. All right. Didn't put 3.5 in this time. That's fine. Okay, you can put it in or not, depending on whether it's helpful. Next one then, I'm doing real numbers less than or equal to 3.5. Okay, so with this one, I have to mark 3.5 on because 3.5 is a real number. Okay, and it is less than or equal to 3.5. So I will mark that on, and I will just mark that that's 3.5. Okay, and then all the real numbers which are less than or equal to that is everything to the left of that. So you're going to fill in the line to the left of that. And then again, it's going to continue down to -infinity. So I'm going to put the arrow in. Okay, because it was less than or equal to 3.5, it would include 3.5, so I put an actual dot there. All right. If it had have said x is just less than 3.5, well then it wouldn't include 3.5 itself, and I would have just done the hollow circle like I did here. Okay, so the same kind of rule would apply even though it's a decimal. Okay, you put the circle there without being filled in if it was just less than, because it wouldn't include 3.5. This one was or equal to, so I put the dot on. All right, so the solving of these is just like equations that we've done before. The graphing then, nothing different, nothing new on this video, bar the fact that kind of decimals came up on graphing one of them, but the principles of graphing these the same as what I did in the previous video.